When students come back to investigate the PhET simulation for nuclear fission, a couple things they'll notice is on this first screen, there's only a single nucleus. And at first they can't figure out what to do, and I kind of reply to them, well, what do you do when you got a toy gun when you were little? And they go, well, I fire it. So we tell them, okay, fire it. And then when they do, they can see that the nucleus became unstable because it was shaking, and then eventually it breaks apart. They may need to do this multiple times before they track exactly what's happening, that now there are 3 neutrons being released as well as the 2 daughter nuclei, and using the key to really see what they're looking at. Then when they move on to the chain reaction, same thing, they have to take the gun and actually fire the gun again to watch how the reaction becomes a chain and how the uranium-235 reacts, but the 238 stops the process. And then lastly, they get to explore with a nuclear reactor, so they can adjust where the control rods are. And this is a good chance to refer back to the difference between the Fukushima reactor, where the control rods were in the bottom, so when the power was lost, the control rods did not stay in them, versus an American-style reactor, where the control rods enter from the top. So in the case of a power outage, the mechanism that controls the depth of the control rod actually will shut down and fall, letting the control rods into the reactor and stopping the reaction.